Hello, this is the AP Calculus PC, problem number 17. This one we need to figure out which one of these four following series converges. So we notice that in each one of these four we have an alternating series as we have a -1 to the n. So to solve this problem we're going to be using the alternating series test. And so the alternating series test basically says that a summation will converge if, first of all, it's alternating. So that means that this specific test only works when you have a -1 to the n or the -1 to the n plus 1. It also, the limit as, we'll call it a of n, goes to infinity, needs to equal 0. Now, a of n would disinclude the -1 part, so it would just be these big boys over here. So if that limit goes to 0, then it passes that part of the test, and then a of n plus 1, as in the next term, needs to be smaller than the previous term. And so if something passes all three of these, then it converges. And there's also another test that I'll bring up in this video. We have the nth term test. And we do not want to use this in this problem. The nth term test says that the summation will diverge if the a of n, if the limit of a of n, I guess I should say, as long as its limit as it goes to infinity is not 0, then it will diverge. That basically means that at very large and large values, it'll have this common constant or ratio that you're just going to be adding up over and over and over again. And it's very straightforward that if that's not 0, if you aren't doing 0 plus 0 plus 0, but if you're doing 1/2 plus 1/2 plus 1/2, then it's going to diverge. So let's check the alternating series test for each of these. So we see A is alternating. Now let's find out the limit. So 1 minus n over n. So it's the limit as n goes to infinity of this. So you're going to have a negative infinity over infinity. Again, this 1 over here doesn't really make any difference. And that over there is not going to equal 0. In fact, it's going to equal 1. So it does not pass the alternating series test. So let's move on to the second problem. We have n plus 1 over 2n. So that's going to be infinity over 2 infinity. So that's going to go to 1/2, which is not 0. So B also doesn't pass it, so we can cross these two out. Now C, we can actually do some simplifying before we go ahead and do it. This is going to be to the 1.5 over 3. And now if we take the limit, this will just go to infinity, because it'll be infinity to the 1.5 over 3. So that's infinity, which is most certainly not 0. And now our last problem over here, we can also do some simplification over here. And now the limit as n goes to infinity of 2 over root n, that's going to be 2 over root infinity, which equals 0, because it's 2 divided by a super large number. So this actually passes the second part of the alternating series test. Now I just need to make sure that it's decreasing. So that's saying that 2 over root n plus 1 is less than that. And as we can see, that is true, because when that number has a greater denominator, the number is going to be smaller. So our answer will be D. And now if you go over and look at the nth term test, we can actually prove that each of these will diverge, because we said that since the limit of a of n as it goes to infinity is not 0, which is true in each 4 of these cases, that means that it will diverge. Now, for the nth term test, you could get a little confused and say, if the limit goes to 0, that means that it converges. That's not necessarily true. To do that, you need to show all 3 of these 3 things are true in the alternating series test. You can't just assume that the converse of this is true, or the inverse of that is true. Anyways, thank you much for watching, and goodbye.